Yeah. Good morning, everyone. Padmaja Bhagvat on this side. I thank you for dialing in today and thank you for showing the interest in this talk this morning. And I personally want to thank Pune developer community for organizing this talk and giving me the opportunity or giving us the opportunity to speak on this concept. So today we are going to talk about a very common type of analysis called cohort analysis, and particularly in that we are going to focus on one particular case study which is called as churn analysis. Okay, so before we dive into the concept to talk about ourselves, we are open source contributors and data scientists, and Bargava here has been my mentor from past 4 years, and he's like one amazing person who has been lead data scientist at all the major companies, and he has founded many successful startups. So currently he's a CTO at Binas, and I'm Padmaja Bhagvat. I am a software developer at VMware, and I love tweaking around with machine learning model every now and then. So enough about ourselves, let's dive into the concept. So today we are going to focus on one particular type of data set, that is telecom data set. So why? Because in this slide you can see the number of customers who are subscribed to this particular service. So there are more than 1 billion customers who are subscribed to this wireless service, right? So just in 1 month, from December 2019 to Jan 2020, we can see the growth in customer base by about 0.43%. So the catch here is, even though this customer base is increasing for wireless service, we can see that not all the service providers are making profit. So you can clearly see that for Vodafone, the customer base has in fact reduced. It has gone down by nearly 1% in just 1 month. So we all know that it is much easier or less expensive to retain the existing customers than to acquire new customers. So we're gonna focus on this major section where we gonna talk about uh, how we can ensure that the customer don't leave our system at all, or at least stick with the product for as long as possible. Okay, so this is how the in general customer engagement life cycle looks like. Okay, so you're gonna advertise your product and you're gonna increase the awareness of the product, and that's how people slowly start engaging with the service or the product that you're offering. And uh, over the period of time, they slowly get converted into paid customers, and they continue using it for certain period of time, and ultimately there are few bunch of customers who totally become loyal to your product. So this is like the ideal life cycle that looks like, but reality is never the ideal case, right? So you're gonna have different scenarios such as customer abandonment, where they kind of explore the features that you provide and never really come back. And there are situations where customer show interest in your features, so they subscribe to your subscription offer and all that, but after that period is over, they never really come back. And the worst thing is, uh, this last stage of customer disengagement, which is called as churn. So this is the phenomenon where the customer who you thought was really loyal to the system, who used your product for certain period of time, all of a sudden they leave the system. Now this is something that has a very big impact on the business. Okay, so you would have already invested too much of your energy and time to nurture this customer, to ensure that the customer remain loyal to the system, right? So this is something that hits the business very hard. So we're going to focus on how or what we can do to understand why the customers are leaving and how can we prevent that churn. So leaving the system is what we term as churn. Okay, so a very easy or very straightforward method to analyze how customers are behaving is using cohort analysis. Okay, so to give you a overview or general idea about what cohort analysis is we gonna divide our customer into different buckets, and we gonna compare the behavior of one bucket with the behavior of yet another bucket. So in this diagram, you can see that we have divided the customer into different buckets based on the month when they subscribe to the model, or to the when they subscribe to the product, right? So you can see that customers who subscribed on Jan of 2011, uh, they are uh, like using the product for quite some time. So on the x-axis you have the month when the customer subscribed, and on sorry, on the y-axis you have the month when the customer subscribed, and on the x-axis you can see the tenure period, which means what was the behavior when they joined the service, and how the behavior varied across different time period. So you can see for the customers who joined on Jan of 2011, the engagement of the customer with your service increases rapidly on the second month, right? So it has the customer retention probability has gone high as 600%. But whereas down the line, if you see on the 13th month, the customer retention reduces to just 27%. Now this is something you would want to avoid. Whereas if you look at the December 2011 data, the customer is sticking with the product even after 13 months, and they are sticking with the product with very high probability. So now you would want to focus on the thing that, okay, what did I do right in this month? What was my advertising strategy? What campaigns did I run? So that you would want to repeat that in the future. Okay, now this entire cohort analysis gives you the overall idea about how customer behaves. But the major thing that you would want to see is cohorts like Jan 2011, where customer end up leaving the product after a certain time. So you would want to understand what exactly caused the customer leave the product. Okay, so we saw how the overall quantitatively you can tell which bunch of customers are going to stick with the product and which bunch of customers are going to leave. Now we're going to focus on what is the exact criteria uh, that is determining whether the customer is going to stay or leave. Okay, so we now are going to focus something called as qualitative analysis, where we see how customer goes from being active to at-risk customer, and ultimately they're gonna churn, right? So we're gonna focus on the features that are responsible for this churn and how we can prevent them. Okay, so let me quickly tell you that survival analysis models, this is the kind of analysis or algorithm that generally people use to make make this sort of analysis whether the customer is going to stick with the product or is not going to stick with the product. So in our case, we're going to mainly use this Cox proportional hazard model. Please do not get intimidated by all these terminologies that I am throwing right away. Okay, so you might just to give the general notion of how the data might look like. So you will be having your customer IDs, various properties such as their age, their gender, and ultimately you will be having this column called as whether they're going to churn or not. So you might think that, okay, why all these fancy terminologies? Why can't I just use classification model to tell whether my customer is going to churn or not? You can definitely do that, but that is not the focus of talk or focus right now here is, because you would want to know with what probability the customer is going to churn. You just don't want to tell that, okay, he's going to churn. You would want to tell, okay, tell me with what confidence you're going to you're telling that the customer is going to churn. And that's when you might start thinking that, okay, if not classification model, let me just go with logistic regression. That definitely gives me the probability with which the customer is going to uh, churn the system, right? So why not logistic regression? So yes, logistic regression definitely gives you the probabilities for the event to occur, but it does not tell you at what specific point of time is that probability valid. So you would want to know that, okay, the customer is going to stick with the product with this much confidence at this point of time, so that you can design your marketing campaign, or you can start giving your the offers right on time, not when it's too late. So that's why we use survival analysis model, and out of which, as I said, we'll be using this cox ph model. This might seem intimidating, but this is a very useful and uh, very easy model to understand. Okay. So all that you need to remember regarding this specific model is Cox PH is going to tell you how each and every feature affects the survival chances of your customer. So whether a particular feature is going to positively impact, or if it is or is it going to negatively impact the survival chances of your customer. So please not, from now on, whenever I use the word survival, think of it as customer retention. Okay, so I'm talking about customer retention because all we care about is retaining the customer, right? So before I go into all the mathematical details, I'm gonna just give you the walkthrough of the code. I'm gonna give you the demo, and I'm gonna try to make you understand how the entire model works. So this is how our architecture uh, looks like. So we're gonna feed CSV data to our model, and we're gonna use these very famous libraries such as Pandas, Lifeline, and Alter to pre-process and model our data. And ultimately, we are gonna build a very beautiful web app out of it using this very cool uh, package, which is my favorite, called as Streamlet. Okay. Let's just directly dive into our code and see how the Cox PH model helps you do churn analysis. Okay. Okay, so as I had mentioned, we're gonna focus on telecom data set today. And yes, this is how our data looks like. So we have customer ID, we have different features such as gender, whether they are dependents or not, what all services have they subscribed to, and so on. Okay, and ultimately we have this column, which is must to have, which tells us whether the customer is going to churn or not. Okay, so the major thing that we need to focus on here is this tenure period. So this tenure means different to different kind of customers. Okay, let me explain this in a little bit more detail. Okay, so you can see that the third customer has already churned when the data was collected. Okay, so for customer like these, tenure period of 2 months indicate that the customer has used the service for 2 months. Okay, and that customer is no longer with us. We can't do anything with that. Okay, but whereas for other customers who are yet to churn, who are using our system, this tenure period of 34 months indicate that the customer has been using the system or using the service from past 34 months, and that customer is going to continue using the service. Okay, and somewhere down the line they might leave. So we need to focus on these customers and see how we can prevent them from leaving the service somewhere down the line. Okay, just remember this concept because we will be revisiting this in later point of time. Okay, so this is the general pre-processing that I've done. As you know, machines don't understand anything other than numbers. I'm just converting all these categorical variables into numeric variables. So, and I'm just removing all the gibberish data such as empty strings and all, and I'm replacing it with specific number. Okay, so ultimately this is how your data set looks like. You have major features such as gender, whether they're dependents or not, and different services that they have subscribed to. And ultimately you have few continuous variables as well, such as what is their monthly expenditure, what is the expenditure that they have done till now for this particular service, and what is the tenure. So the best part about CoxPH model is you don't have to worry about separating categorical and continuous data. So for those who have been doing machine learning from quite some time, you know this is a really painful point in the data to segregate these two and do the analysis. So CoxPH model, you can feed in both categorical and continuous values, and it is going to do the analysis on top of it. All right, so here ultimately we are gonna start building our model. So we use this very beautiful library called as Lifeline, which has different survival models implemented. So again, as I had mentioned, we are going to stick to CoxPH today. Okay, and yeah, given this raw data or process data, you can say, we're gonna split it into train and test in this particular step. Okay, 80% of the data you're going to use it for training, and 20% of the data you're going to use it for testing your model. So let me just run this CoxPH model and see what it gives. Okay, so it gives this very beautiful explanation of the model. So you can print the entire summary. This might look intimidating. Let me just quickly show you the visualization and go back to the numbers that were shown above. Okay, so in here on the x-axis, before x-axis, let me explain what is there on y-axis. So you have different features that we picked for analysis in the beginning. And on the x-axis, you have the coefficient of each and every feature. Okay, so what you need to remember here is, higher the coefficient, lesser the chance of customers surviving or sticking with the product because of that feature. So all that I'm trying to say is, you would want to focus on the features which are having less coefficient values. So here you can see that bank transfer, credit card uh, type of payment, contract 1 year and contract 2 years have negative coefficient. So this means that these are the features which is going to boost the survival chance of your customer. So you might want to focus on these features. You might want to give some offers or whatever you're planning to, and somehow you want to focus on these features in order to boost the survival chances. And that's exactly what is given in detail in the sprint summary. So it's giving you the exact number, exact coefficient, or the chances with which the specific feature is going to boost the survival chances. Whether it is going to boost or it is going to hamper, you can tell it based on whether it is positive or if it's negative. If it's negative, then great, you want to focus on that feature. Okay, uh, so this is how we yeah, we did the general overall analysis of the model, or sorry, the data, right? So we took the data, we are now we processed it, and we saw, okay, what are the features that are important and all this. But the next major thing to do is uh, to focus on to focus on the customers who have not yet churned. But before I go to that, let's see how the survival curves look like for different customers. So I'm picking one specific feature called as total charges. Okay, and I'm seeing how the survival curve vary for different total charges. So for the customer who has not spent anything, you can see that the survival curve drops very quickly. But for the customer who has spent nearly 4,000 rupees for the service, you can see that the customer sticks with the product for longer period of time. Okay, only after 50 months or something, they start leaving the system, leaving the service. Okay, so on the x-axis you have the tenure period, and on the y-axis you have the probability with which the customer is going to stick with the product. Okay, so yeah, this is all well and good. We now know what are the features that we need to focus on. Let's quickly dive into what predictions that we can derive out of this model that we have built. Okay, so the thing over here is this entire analysis in the previous step, you did it for the overall data. So now what you can do is you can focus on retaining the customers who have not yet churned. You can't do anything with the customers who have already left your system. God bless those people, but you can't do anything. Okay, so let's just focus on the customers who have not yet churned, right? So that's why I am just picking that data out of my data set, and those are the customers who are called censored subject. So terminology alert, this is something that you will come across again and again. Okay, so censored subjects are the one who are continuing to use your products, who have not yet churned. Okay, when the data was collected. So here we can see that in our data set we have more than 5,000 people who have not churned. Okay, who are sticking with your product. So let's try to do some prediction. Let's try to see how much more time are the customers gonna spend with our service. Okay, so we do use something called as predict survival function. Okay, so this predict survival function, what it does is it tells you the different probability with which the customer is going to use the service over different period of time. Before I bore you with all these numbers, again, I would want to jump to the visualization for one particular customer, who has the customer ID of 1452 blah 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 blah. Okay, so here you can see two different survival curves. So the one in the dotted line shows that this is unconditioned survival curve, and the one which is in bold shows you the conditioned survival curve. Now, what is the difference between these two? So when you feed this data to your model, it just thinks that whatever tenure period that you have shown, that is like the total lifespan of the customer. Okay, but that is not true. We know that the customer is going to use the product even after this tenure period because the customer hasn't churned yet. So we need to condition our analysis based on the fact that the customer is going to stick with the product for little longer time. So for this customer, you can see that the tenure period is 22 months. So on the x-axis you have the months, tenure months. So till 22nd month you can tell with 100% surety that the customer is going to stick with your product, and it's only after 22 months the chances slightly keep reducing. Okay, whereas if you had not taken that into consideration, you will end up predicting the month. I mean, you end up predicting the churn way before it is actually going to happen. So you don't want to do that. Okay, so this is how these two curves vary. It's all, so now we have seen what are the features that are important, and we have seen how the survival curve looks like for a specific customer. Let's now see what are the action that we can take on this particular uh, bunch of customers. Or let's, as I mentioned, let's stick with this specific customer. What can I do to retain the customer? So that's the question that we're gonna answer, and let's try to derive some actionable insights. Okay, so this is like the graph which tells you the survival chances over different period of time. Let's just stick with the month where the survival chance of the customer gets reduced to half. So here we do median survival times. We use this function to get the month where the survival chance of the customer is just 50%. Okay, so you can see that on 22nd month, survival chance of this specific customer gets is just 50%. So there's 50% chance that the customer is going to leave your system. So you might want to start taking some action on that 22nd month, right? So you can vary that percentage depending on your requirement. So for that, again, Lifeline provides a very nice function called as QH survival time. So you can vary that percentage. Either you can do 50% or 90%, 75%, whatever it is, depending on your requirement. So right now we're going to stick with the time when the survival chance of the customer is just 50%. Okay. So again, you can see that for this customer on 31st month, the survival chance of customer gets reduced to half. And now that we know this, let's also see what is the value that what is the remaining value that the customer can add to the service. So this monthly charge, assuming that the customer continues to spend this much, we see that the customer has remaining value of around 800 rupees. Okay. So we saw that the tenure period of this customer is 22 months. When I printed this particular row, we saw that the tenure period of this customer is 22 months. And we predicted that on 31st month, there is 50% chance that the customer might leave. And this is the remaining value that the customer can add. Okay. All this is well and good. So this is all the analysis or insights that you have derived with the data that you currently have. You haven't done any good sort of analysis or predictions yet. So the major question that we need to answer is, okay, now tell me finally what can be done to prevent this churn and to make sure that this value goes extremely high, not just 800 rupees. I want to ensure that the customer adds way more value than what he's currently going to add. Okay, so let's dive into the next section of our talk, which is like the most important and the most interesting part of the talk, which tells you what can you do to prevent the churn, what are the features that you can focus on, and how does that feature boost the survival chances of your customer. Okay, so in the very beginning itself, we concluded that these are the four features which impact your survival chances of the customer positively. So let's just stick to those four features, which is payment by credit card, bank transfer, contract 1 year, and contract 2 year. So what I'm going to do is I'm going to do a little bit of trick over here. So I'm going to make the customer subscribe to all these features. And I'm going to see how is it gonna impact the survival chance of that particular customer. So again, I am sticking with just one customer here. So what I'm doing in this entire function is I'm getting them subscribed to this specific feature if they are not already subscribed. And if the customer is already subscribed, I'm unsubscribing it. I know this is something notorious that I'm doing, but I'm doing that so that I can know that what is the impact that unsubscription is going to have. Okay, so you can see here that the customer is subscribed to credit card and he has not subscribed to any other major features that we are interested in. He has not subscribed to bank transfer, 1 year contract or 2 year contract. So this is not something that I have predicted. This is there in data itself. So what I did in the above function is I'm going to revert this entire functionality. Okay, so I'm going to make the customer unsubscribe from this credit card and I'm going to get them subscribed to all the remaining major features. And I'm going to see how the survival rate improves. So we saw that at around month 27 to 30, the survival chance of the customer gets reduced to half. But if you just get the customer subscribed to, let's say, bank transfer, you see that the baseline has really improved. It has gone up from 27 to 31 months. Okay, so just by getting the customer subscribed to one specific feature, you are boosting the survival chance of that customer. Whereas I unsubscribed the customer from using credit card feature, right? So you can see that impact right over here. So you can see that the survival chances has gone down from 27 to 22 months. And the very interesting insight that you can derive from this is from this 2-year contract feature. So this has increased the survival chance by around 30 months, which is a huge boost, right? So this tells you how much impact the specific feature has for the survival time. But what we would be more interested is to understand the monetary value associated with that, right? So assuming that the customer is going to do the same amount of monthly expenditure for the remaining period of time, we can see that by getting the customer subscribed to this 2-year contract, we gonna have a huge boost of 2,600 rupees, more than 2,500, which is like a huge boost. You're gonna have a profit of this much rupees. Whereas if the customer unsubscribes credit card due to some reason, you can see that you're gonna have the loss of around 450 rupees. Okay, so you would want to ensure that the customer sticks to these features. So you would want to give different offers or different promotional, you want to use different promotional methods such that the customer use these features and they subscribe, because you can see the huge monetary refund, monetary value that these features are going to add. All right, so this is something that any of our management committee would be interested to know. So now that I've finally gained your interest, so you might already have started to think that, okay, now let me try doing this entire thing for my company data. Let me do this analysis and let me show off my amazing skills. Before you do that, uh, I want to tell you that, okay, I explained this entire concept using notebook. You cannot demonstrate this using this notebook to your management committee, right? They won't be interested in how you did the analysis. All they'll be interested in is, what is the analysis that you did? Okay, tell me the end result. What am I supposed to do and what am I not supposed to do? So so to present this entire things that I explained just now in more intuitive way is to visualize it. Okay, so for that I use this very cool package called as Streamlet. Okay, so for some which gives me this web application handy. So here you can see that it has all the very cool visualizations with all the explanation. This is what exactly your management would be interested in. So you can uh, see the raw data and how the processing happened and all the various models that I just demonstrated over here. So for someone like me, who has bare minimum knowledge of HTML and CSS, and let alone learning the concepts like Angular and all that, so for someone like me, the Streamlet is a bliss. Okay, so you just have to invest like bare minimum time to learn this, and you can implement it right away. So this is something that I did in just couple of hours. So if I, with no knowledge of UI, can come up with such cool dashboards, I wonder what people with very good background in UI can end up doing. So it's not just the static data that the Streamlit ends up showing. You can make this entire web application very intuitive and very much what you can say, interactive. So I'm going to demonstrate one specific section of the entire talk, which is predicting churn section in yet another web application, and I'm going to show you how can you make this intuitive. So in this, I've given all the static data, right? So I'm going to move to this Streamlit application, so where I'm focusing on prediction and prevention of churn. So here you can select any one customer, and we're gonna walk through the entire process of predicting and preventing the churn. All right, so by default, this is the customer that is selected. We can see this is how the raw data of the customer looks like. Okay, and it processed and it is showing me different survival curves. Okay, the conditioned and unconditioned that we spoke about. And it is now let us focus on the prediction part that we just did in the last section. Okay, so we can see that on 49th month, the survival chance of this customer gets reduced to half. Okay, and the tenure of this customer is 34 months. And we can see these are the features that the customer has either subscribed to or unsubscribed to. So you can see the customer has subscribed to credit card, bank transfer, and 2-year sorry, the customer is subscribed to just 1-year contract and has not subscribed to any other feature. Okay, so now let's just get them subscribed to all these features that he has not already subscribed to, and see how that is going to impact our survival analysis of this customer. Okay, so you can see that by getting customers subscribed to this 2-year contract, you increase the survival chances drastically. So on the y-axis, you have the chances of customer or probability of customer using the product. Okay, and this red line indicates the baseline that you currently have on the current data, and these bars indicate how that survival chances is going to improve because of the features that we are showing right now, right? So you can see that for all the features, for all the credit card payment, bank transfer, and 1-2-year contract, the survival chances have gone much above the baseline. But whereas for 1-year contract, it has come down. Why? Because we unsubscribed the customer from that feature, and now we can see that the survival chance has gone down. And here you can see the monetary return. So you can see by if for whatever reason, if the customer stops using this 1-year contract feature, the monetary value drops drastically. So you would want to ensure that the customer never unsubscribe to that feature. And you can see that how other feature, subscribing to other features are going to boost the monetary value of the service, right? So you would want to give a lot of offers, do whatever you can to get customers subscribed to 2-year contract, especially because that is going to boost your monetary value crazily, right? So you can just change it to a different customer, and you can see on the real-time basis this entire visualization changes, and it gives you the entire prediction for this particular customer. So you can even cache this entire result. I have not done that. So that's why you see a little bit of lag while loading the data, right? So here you can see that the again on 25th month, the survival chances reduced to 50%, and this customer is very nasty. He hasn't subscribed to any of the features that we are looking for, right? So if you get them subscribed to all these features, you see how the survival chances improves and how the monetary value because of those features are going to be improved over the period of time, right? So before you get all puffed up and all happy to do all this sort of analysis for your company data and show this to your management, you would want to just take a step back and think, okay, how good my model actually is, how accurate are those results are, right? So let's focus on this next section of the talk, which is called accuracy and calibration. So for models like survival analysis, you would want to focus more on calibration than accuracy, which basically tells you how well your model is getting the probabilities right over different period of time. Okay, so you want to ensure that the model is very well calibrated to tell that okay, whatever numbers I'm telling it with full confidence. Okay, so if I say that the customer is going to stick to the product with 90% probability on, let's say, 10th month of subscription, so that means the customer should actually be sticking with sticking to the product with 90% probability. It should be that good. Whatever numbers you state should be really accurate for different period of time. Okay, so for that, let's focus on one particular tenure period, which is on 13th month, a tenure period of 13, and see how your model is calibrated. So this dotted line shows the perfectly calibrated model, and this blue line indicates the calibration of the model that we just built. So as you all know, the ideal calibration is just there in fairy tale. Is just for fairy tale. Okay, real world is very messy, and we would want to make sure that our model gets as close to ideal scenarios as possible. Okay, so here you can see that our model is almost close to the ideal scenario, but you can see that for mean predicted value less than 0.5, the model somehow over predicts the risk. Okay, it might say that the customer is going to leave sorry, for the value less than 0.5, the model is actually under predicting the risk, and for the values above 0.5 it is over predicting the risk. So if it might be such, it might give you false alarms. It might say that, okay, look, the customer is going to leave the system, but they might not actually leave the system. So what can you do, what can you do to ensure that this calibration is nice, and yeah, and to tell this with much more confidence, you're gonna calculate something called as barrier score loss. So as we all know, in machine learning, loss indicates the difference between the actual value and the predicted value, and you would want to ensure that this loss is as minimum as possible. So in this particular visualization, we just focused on one tenure period of 13 months. We're gonna see how the model performs over different period of time. Okay, for different period of time, and how the loss values vary. So you can see that from around 5th month to 30th month, the loss of the model is very minimum, and you can tell with full confidence that, okay, whatever prediction the model has done for this tenure period, I'm very confident about the numbers that I'm stating, right? So after 30 months, you see the loss keeps getting increased. So this is mainly because we don't have enough data regarding those customers who are sticking with the product for longer period of time. Okay, but the best thing is, you would somehow want to focus on lesser month only, lesser tenure period only, because it's the very beginning of the subscription when the chances of customer leaving the product is extremely high. Once the customer uses the product for certain period of time, they are going to end up sticking to the product for longer period of time. So the good thing about this is, it is giving you the predictions with much more confidence for initial months, right? So here we are just going to calculate, okay, what is the lower bound or upper bound. So basically what I'm doing here is, for 2-year contract, I told you that just by getting the customer subscribed to this feature, the monetary value is going to be boosted by 2600 rupees, right? So this is not, this is not exactly 100% accurate. So what I'm telling right now with this calibration is, okay, it can vary somewhere between 2100 rupees to 3100 rupees. Okay, so you can get the profit from around 2000 to 3000. So this is the lower and upper bound, it will not go beyond this. Okay, and whereas if you look at this credit card feature, so I told you that you're gonna have the loss of 450 rupees because the customer unsubscribed from this feature. But again, this is not the exact number. It might vary somewhere between 360 to 523 rupees. The loss might vary somewhere in between this. So yeah, this is what the overall idea of survival models are, and how you can analyze a specific data set, and how you can tell what are the features that you need to focus on, and what are the monetary values that the specific feature is going to add. So this was mostly the various steps that are generally followed. And the best part in this talk, at least according to me, was this very cool visualizations that you get. So you can definitely show this visualization to your management with full swag, right? They're gonna be really impressed. Yeah. So coming back to our slide deck, these are the major references that we used. So if you're a geek like me who would want to understand, okay, how does this Cox pH work? Like, it gives so much, it gives so many useful insights. I would want to know the mathematics behind it. If you want to learn the statistic behind it, you would want to go through these references. And now that you know how this model functions, you can relate to it very easily. You know, okay, what does conditioned survival function mean? What is unconditioned survival function? What are the so you can relate with various terminologies that are going to be used in different papers very easily, because now you know the functioning of the model, right? So yeah, this is the references that I strongly recommend you guys to go through. And yeah, if you have any questions or if you have any suggestion, please feel free to contact us. This is our Twitter handle and LinkedIn ID. My LinkedIn name is Padmaja Bhagvat. And we're gonna very soon make this entire repository public. Okay, so if you have any contribution to make, or if you just want to use the code and play around with it and see how it does for your data, how it works for your data, we're gonna make it public pretty very soon. Okay, I hope you enjoyed this talk. Now I think I'm gonna open myself up for Q&A. So yeah, Bhagava, over to you.
Oh, we don't have any questions so far. Does anyone have any questions? You can post it on the comments.
Okay, yeah. Awesome. So we're gonna very soon make this repo public, as I said, and we're gonna post the link of the repo in the description of this video. All right. So you can anytime contact us for any questions that you might get somewhere in the future. All right. Thank you so much for getting up on the Sunday morning and yeah, attending this talk. I really appreciate your time. Thank you.
Thanks, everyone.